So here we're asked to solve the trigonometric equation 2 sine squared x plus 3 cosine x equals 0. Now when you're trying to solve a trigonometric equation, you want to have, if possible, a single trig function. So either sine or cosine, but not both if we can help it. So we're going to try to find an identity that will help us. Is there any way we can change sine squared to cosine squared? Well, we do have that identity that sine squared x is equal to 1 minus cosine squared x. So what we're going to do is replace our sine squared x with 1 minus cosine squared. They are equivalent according to our identities, so that is okay to do. We're just substituting something it's equal to. And that will allow us to solve because now we have just a single trig function. Cosine is all. Let's simplify, so I'm going to distribute the 2, and that gives me 2 minus 2 cosine squared x plus 3 cosine x equals 0. Now on this one, notice I have both a cosine squared and a cosine, which when we're solving equations, when you have both an x squared and an x, you know that you're going to have to either factor or use the quadratic formula to find your answer. And when that happens, rather than trying to get the cosine by itself, what we do is we get the equation equal to 0 and then try to do either of those, either factoring or using the quadratic formula, excuse me. So what we're going to do is put these in order. So usually we write cosine squareds, or the squareds first, and then our first power, and then our constant on the end. The other thing is it's a little more difficult to factor when you have that negative there. So I'm just going to divide both sides by -1 so that my cosine squared is positive. So now I have 2 cosine squared x minus 3 cosine x. Notice all it does is it changes all of my signs. Minus 2 equals 0. Now I need to try to factor that. It is exactly like factoring other polynomials. It looks more confusing because you have cosines there. So if it helps you, you can replace your cosines with something else while you're factoring, just to get your factoring done. And I'll do that over here. I'm going to come over here and factor. I'm going to change my ink color. Okay, so again, I'm trying to factor 2 cosine squared x minus 3 cosine x minus 2, right? So I'm going to replace, I'm going to say, let's let cosine instead, let's let it be u, okay? So we would have 2u squared minus 3u minus 2. And you don't have to do this, but if it makes it easier for you to factor it and then come back to the problem, I would do that, okay? So here we go. We need to factor this. Now notice we have a number multiplied on the front, so it factors a little bit differently. I do this usually by grouping. I'll show you that method, but if you can factor it by guess and check, that's fine too. So the way I do this is when there's a number in front, you take the first number times the last number, and that gives me -4. And we want factors of that number that add to equal the middle number, -3. Well, -4 times +1 is -4, and -4 plus 1 is -3. And this is just another method for factoring. I don't know if you learned it this way or not, but it works. Okay, so now what we do is we replace our 3 with the 2 numbers we had here. So we keep the front the same, 2u squared, but instead of 3u, we write it as -4u plus 1u. That is the same as a -3u, so it's okay. Okay, and then we factor by grouping. So we group the first 2 together and the last 2 together and factor out common factors. So in my first set here, 2 goes into both of those, and u goes into both of those, and I have left over u minus 2. In this set, they don't have any common factors. If they don't have any, you at least take out a 1. We call it 1u minus 2. Okay? Well, now notice I have a common factor. That's factoring by grouping. You pull out what the sets have in common, and you end up with a common factor again. So notice this term has u minus 2, and this term has u minus 2. So I can factor that out, And my other factor is whatever was left over. So here when I took out the u minus 2, I had a 2u left. And here when I took out the u minus 2, I had a plus 1. Okay? So I don't know if that's how you learn to factor when there was a number in front. Maybe not. But it is a way that you can do it every time, and it doesn't require guessing and checking. Okay? All right. So there are my two factors. Now I'm going to go back over here and put back my cosine. So remember, u was actually cosine of x. So my factors here are cosine x minus 2 and 2 cosine x plus 1. So if you were able to do that, I can usually do it without, using the substitution. But if it makes it confusing having the cosine there, pull it over to the side and factor it using just a single variable, and then come and substitute back in. Okay, so we came down, we isolated, we got it equal to 0, we factored it. Remember, the next step in solving these equations is you set each factor equal to 0. So cosine x minus 2 equals 0, and 2 cosine x plus 1 equals 0, and you solve for x. Okay, so here I add 2 to both sides, and I get cosine x equals 2. If I try to do the inverse cosine here of both sides, remember cosine can never be greater than 1, and if you try to do the inverse cosine of 2, you'll get an error. So this answer over here actually gave me an invalid answer, so there's no answer coming from this one. I come and solve this one.
All right, so we go ahead and we subtract 1 from both sides. So then we have 2 cosine x equals negative 1. Divide both sides by 2, and I get cosine x equals negative 1/2. So now we need to find, and our question is, what angle has a cosine of negative 1/2? You can find that by doing the arc cosine or inverse cosine on both sides. So x is the arc cosine or inverse cosine of negative 1/2. Right, so if you put that into your calculator, you will get x equals 120 degrees. We want to put plus or minus 360k so that we will get every time we go around the circle. But remember, there's also another value on the unit circle where cosine is negative 1/2. Cosine is negative here at 120 degrees. Okay, it's also negative 1/2 down here in quadrant 2. Now remember, this was 60 degrees away from our x-axis, so we want the angle 60 degrees away from the x-axis here. So if we just take our 180 degrees and add 60, we know we have a 240 degree angle. Okay, so our second answer here is that x is equal to 240 degrees plus or minus 360k, and that's if our answer is in degrees. Again, our other answer here did not give us any valid solution, so we only ended up 2. But when you're factoring like this, you do have the potential for 4 sets of answers that you might have to work through.
All right, here's another one. Let's try and solve this. We have cosine squared x plus 4 sine x minus 2. So again, notice we have cosines and sines mixed. If possible, we would like to not have that. And anytime there's a cosine or a sine squared, it's an easy fix. Okay, we want to write this all in terms of sine. And we know that cosine squared x from our identities is equal to 1 minus sine squared x. So we are going to replace this cosine squared with a 1 minus sine squared. Okay, and now solve the equation. Again, we have a sine squared and a sine. Okay, so we know in order to solve this, we can't just isolate the sine. We're going to have to either get it equal to 0 and then either factor or use the quadratic formula to finish solving this. So let's go ahead and do that. We want to get it equal to 0, so I'm going to add 2. I would add 2 over here. That gives me 3 minus sine squared x plus 4 sine x is equal to 0. Let's put it in the order we're used to seeing it, with the squared first. So we'd have negative sine squared x and then the sine plus 4 sine x, and then plus 3. Next, again, this negative makes it tougher to factor, so I'm going to divide everything by negative 1 so that I'm not dealing with that. So now I have sine squared x minus 4 sine x minus 3 is equal to 0. Okay, so now what we're dealing with is either factoring or the quadratic formula, and the way you can tell is you try to factor it. Again, you can substitute something for your sign, maybe call it u, so that really what we're working with is something u squared minus 4u minus 3. For that, you would need factors of negative 3 that add to be negative 4. Now, the only way to multiply to get negative 3 is either to do negative 3 times 1 or 3 times negative 1. This would give me a sum of negative 2, and this would give me a sum of positive 2. So this is not factorable. Instead, we're going to have to use the quadratic formula. Okay, so remember the quadratic formula is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a, where a is the coefficient of our squared, b is our coefficient here, and c is our constant. So we substitute those values in. B is negative 4, so we have negative of negative 4 plus or minus the square root of b squared, so negative 4 squared, minus 4 times our a was 1, and our c is negative 3, all divided by 2 times 1. Okay, here I get 4 plus or minus, negative 4 squared is 16. Negative 4 times 1 times negative 3 is a positive 12. So we go ahead and add those. 16 plus 12 is 28. So we have 4 plus or minus the square root of 28 divided by 2. Let's find each of those values. Okay, so 4 plus the square root of 28 over 2, and 4 minus the square root of 28 over 2. So I get 4.6 approximately, and negative 0.65 approximately. Okay. Now remember what we found here is what u was equal to from our problem that we were trying to factor. So we have u is equal to 4.6, and our u, whatever that is negative 0.65. Well, u was representing our sine. So our answers over here are that sine x is 4.6 and sine x is negative 0.65. We want to solve for x, so we have to use the inverse sine of both sides. Okay, that leaves me with x equals, and remember sine can't be greater than 1. Okay, and so this will give you an error. This will give us no answer here. But here, if I do the inverse sine of both sides to try and find that angle, I get about, it says, negative 40.5. I'm just going to round to the nearest degree. So about negative 41 degrees. That is the one answer your calculator will give you. But then you have to remember that negative 41 degrees, if that's one of the answers, where is sine also negative? It's also negative in this quadrant. So 41 degrees away from 180. Okay, so if we go 180 plus 41, we get 22.1 degrees. Excuse me, 221 degrees. I cannot talk. 180 plus 41 is 221. So we have an additional answer that x is 221. We want all of the other answers that would come up as we revolve around that circle. So we go plus or minus 360k and plus or minus 360k. And there are our answers to this problem.